Hello everybody, for this video I'm gonna go through a lot of problems. We will be discussing alkanes, alkenes, alkynes, as well as alcohol. We will be going from condensed formula to the IUPAC name, and we will be going from the IUPAC name to the condensed structural formula. This is a good review video if you want to have a couple of problems just to see where your understanding is, or if you really understand the material. Check out my previous video. If you're able to do those examples regarding IUPAC, then you're pretty good. But if you're 9, you need more if you need more examples to do, then this is the perfect video for you. Off the bat, we will start with the first formula, the first molecule. Let's see. We need to first label out all of the carbon. So find the longest carbon chain. Here there's only one, and there are 5 carbons. So the first one's pretty easy. This is a pentane. Let's go down. This one, there's a substituent here, so it only makes sense that we start numbering it from this side over. 4. So the answer is 2-methyl butane. 4 carbons means butane. There's on the second carbon, there's a methyl group. Perfect. Let's move on here. Off this case, I have to find the longest carbon chain, which in this case is gonna be right here, starting off here. Seven. I could go up, but that would also give me 7. If I go up, let me show you guys. I'm sorry, it would give me 6. So obviously the longest carbon chain is on the bottom. And now comes the name. Let me highlight all the substituent for you guys. This is a substituent. Perfect. For this molecule right here, I'm going to use the common name isopropyl to name this molecule right here. I will call that isopropyl. In the last video, I only did IUPAC nomenclature. So for this video, I'll stay loyal and do common names. So hopefully you guys got 4 isopropyl, 2-methyl heptane. As you can see, I counted the I here. As I was mentioning in the previous video, I counted the I here and in the alphabetical order. Pretty weird, right? But I don't count the other suffixes that usually go there. So for example, if it was tri or tetra or whatever, I wouldn't count those. Cool? Cool. Let's start off with numbering this. First, I have to find the longest common chain. Off the bat, it's gonna be this chain right here. I think that's kind of clear. But now I have to ask myself the second rule: which one gives me the lowest carbon count? Well, the lowest carbon count I get right here. Just right here. And there's a substituent. Right here, right here. And so the name for this would be 2,4 dimethyl hexane. Got it? Now we're gonna go create the condensed structural formula to the IUPAC name. Again, draw now in the previous video I went from bond line to from IUPAC. I went from the IUPAC name to the bond line. In this case, I'm going to go from the IUPAC name to the condensed. So let me just make this smaller. Perfect. So off the bat, I noticed there's a dimethylbutane. So I have a butane as my longest carbon chain. Let's draw that out. There are 4 carbons here. Sorry, it's not that neat. And from this carbon, on the second, there are 2 methyl groups. And 2 methyl groups. Perfect. Try this one. This one has a common name in it, so beware the common name. As long as you know how it looks, then you should be pretty solid. And if you can't do it like this automatically, no problem. Just do it in bond line, and then you could get condensed from there. So heptane, which is 6 carbons long. For this case, I put CH because I know that there's going to be isopropyl here. So I'm running out of room, so I'm kind of branching the line here. Got it? And remember, you're not going to have a charge anywhere around these molecules. So that's another way to keep track of your hydrogen. For example, I know that this is CH3 because a CH3 molecule looks like this, and it's bonded to another substituent. Same thing for the middle one. There's one hydrogen it's bonded to. Bonded to an R group. Put here 1, 2, and then it's bonded to another group. Do you see how I'm able to narrow down CH? Perfect. Let's go on. Again, step at a step. Start off with the longest carbon chain, which in this case is a hexane. Yes, this time I stayed in the lines. 3. Hopefully you guys got that. Let's go down. There's a dimethyl octane over here. Octane just means that the longest chain is octane. That's rather large, but no problem. You usually would want to, even though this is octane, you don't want to be curving off. You always want to have like the single longest chain in order to keep bond lines in order. So as you can see, I'm trying my best trying to stay loyal to bond lines, like as if this was a tetrahedral or something or anything like that. I'm staying loyal to the bond line structure. And the same rule applies when you're doing bond line or condensed. Just do this real fast. To this carbon right here, carbon 4 has ethos attached to it. Again, I'm going to go off screen. Now, Diethyl, if you remember, ethyl is 2 carbons. So good. Usually you wouldn't draw your bond lines in a complete straight line, but in this case I can because there's obviously a carbon here, so I'm kind of showing it's 180. But if I did that with a bond line structure, you really can't tell that there's a molecule here or here. But if it was triple bonded, guys, then I could just do it like this. Then it's obvious that there's a carbon here and then there's a carbon here. Cool? Cool. So ideally this is the most loyal to linear. So I can't do this for bond line, but I could do it for here. And this is most loyal to linear. Because again, if you remember, 180 degrees for linear molecules. Let's go down. Now we're going to go into alkenes. Don't let this scare you. There's only one double bond. Yeah, So let's start numbering them. I have a methyl group here and an ethyl group here off the bat. But that doesn't matter right now because I have to find my longest carbon chain. So my longest carbon chain is going to be this. This is my longest carbon chain. And understanding that, I have, where do I start? If I start here, if I start at the very bottom, I will get a methyl group on my third substituent. But if I start here, I get one at the second substituent, which is rule 2, and that's way better. So start numbering this. And yeah, now let me write the IUPAC. You guys should be able to do this now. Just remember for double bonds, they're alkenes. So you're just going to end it with alkene. Like that. Start off here. 4. So it's a 4. And you're just going to write butene. But let's say if I just wrote butene, how would you know there is a double bond in carbon 2, 3, or 4? How would you know? Well, you can't. So I will just indicate that there is a double bond here at the carbon 1 atom. Cool? The reason why I put 1 here is because I'm indicating, hey, at 1 I'm doing a double bond. Hence it's a butene. Let's go down. Let's find the longest carbon chain for here. Off the bat, the longest carbon chain is gonna be, hopefully you guys got right here. So that's the longest carbon chain. Substituents, you're gonna have an isopropyl group here. So you have an isopropyl group here. That didn't make much sense. So this is your isopropyl group. Again, if your professor just wants strict IUPAC name for it, then that would be a complex substituent. For this, I'm gonna just do common names. Let me highlight my other substituent right here, which is a methyl. So again, if you remember, iso counts. Hexene. Again, I wrote 3 here to indicate that there is a carbon bond happening at 3. Do you guys see that? If you guys haven't see that right now. Cool? Cool. Move on. Find the longest carbon chain. This is a really fun example, actually. The reason why this is really, really cool is because I see I have a methyl group here, for example. I see I have a methyl group here, but I also have a carbon bond here. So, which way would I start numbering? a real fast refresher for you guys, it will be from this chain right here. I could have went up or down just like going across because, you know, condensed formula and going on a tangent here, but yeah. So you have 4-methyl. At 2 is when the carbon bond is forming to the pentane. Have I been putting ene everywhere? Yeah, I have. Perfect. Let's move on. You have a 2-hexene, so indicating that there's on the second carbon there is a double bond forming to the 3rd carbon. Let's write that down. Now I'll be doing condensed formula for these alkenes. Pause the video if you guys want to give it a shot. Running out of room. And by the way, that's very sloppy. You want to always indicate that your bond is coming from the carbon to the carbon. You don't want to be drawing a line from hydrogen. In this case, it's kind of referred to as yeah. Guys, got it? Got it. Let's move on. Try this one, guys. So again, I have a bond on the 2nd carbon to my 3rd carbon. I know this from this. So hexene is going to be yeah, I fit it in the lines today. CH3. Got it? Cool. Let's move on to this problem. 3-ethylmethyl 2-pentene. Pentene indicates it's a 5-carbon chain, and there is a double bond on the 2nd carbon chain to the 3rd carbon. Let me show you guys. For this case, since I'm running out of room, usually you would put it straight up because this is at 180 degrees. But just for this, because I was running out of room and I didn't want to branch off to the other section, I'm just going to do this like that. Cool? Cool. Go here. This is the 5-ethyl 3,6-dimethyl 2-heptene on the 2nd. So my longest carbon chain is heptene, which is 7 carbons. On the 2nd carbon, making a bond to the 3rd carbon, there's a double bond, which is indicated right here. And let's do that then. Second carbon. Now, automatically I notice, hey, okay, on my 3rd carbon is the center of attraction. Is there anything coming off of my 3rd carbon? There is a methyl group coming off of my 3rd carbon. See that right here? So, yes, sorry, kind of got confused there for a bit. Automatically I notice that on my 6th carbon there is a there's a methyl group on my 6th carbon. I'll do that later. Let me just do this real fast. Oh, I'm sorry, this is a I'm gonna branch off here. So on my 6th carbon there's a methyl group. And on my 5th carbon, which is this one, there is a ethyl. Let me just label it for you guys. Since this one, a lot of things were going on. 7. So this is my longest carbon chain. This is my methyl here. This is my methyl here. So just highlight this here. And I had a 5-ethyl right here. And let me just kind of feel free if you guys didn't get this problem. Feel free to make sure you always check your work. I'm flying through these right now. But yeah, on your exam, you won't most likely have this many. This is for me just to give you guys as much problems as possible. Now we're moving on to alkynes. 3 carbons. What? A sigma and a double pi bond on that 3rd carbon. Whoa. Okay. Pretty cool stuff, right? So, let me just get this. 4. Perfect. Off the bat, you guys can see the methyl group here. The name for this would be 3-methyl 1-butyl butene. Right? Butene, because there's 3 carbons. Again, you can see the triple bond took preference over the sigma bond to the methyl group. Move on. Find my longest carbon chain, which would be this one right here. Okay, it's a 7 carbon chain, so it's a heptene. What takes priority? Well, off my 2nd carbon, it's making a triple bond to my 3rd carbon, while I have a methyl group on my 3rd carbon. Obviously, it's going to be the triple bond. Again, on an exam, you'll never make it. You won't ever curve it like this because it's not bond. It's not following bond angle. Your professor will only do this to trick you. Literally, there is no other reason why they didn't make this into a straight line. So don't fall for that. Let's write the name for this. I made a mistake here. Hopefully you guys got that. Let's move on. Off the bat, I want to label this molecule. So this is my longest carbon chain. Triple bond again takes fancy over to sigma bonds. And again, it's on the lowest carbon as well. So carbon 2 rather than on a carbon 4, as you can see. Methyl. Let me just write the name for this. Dimethyl, because there's 2 methyls on the same thing. And yes, you have to show it. You can't just write 4-dimethyl. You have to show 4-4 dimethyl 2 hexene. Perfect. Hopefully you guys got that. Now let's go on. Automatically, I know where I'm gonna start now. But and I already see my longest carbon chain. Hopefully you guys do too. This is the longest carbon chain. And I'm doing only common names for this I'm not going to do complex. So this is the isopropyl group. So let me just write it out for you guys. Name for this would be 3-isopropyl 1-hexene. I'm sorry, this should be an E. Hexene, such as what's an E. So, cool. Move on. Now we're going to be discussing, what am I doing? Wait, for all of these molecules, sorry, I get mixed up. A good way to memorize this is, that alkanes are single, alkenes are, double, alkynes are triple bonds. Got that? It's kind of like it follows the alphabetical order. So, yeah, these are Y, by the way. Just kind of specify it. That should be good. Mistakes. Happy little accidents. They're happy little accidents as long as you can catch them. That's right. Now let's do this. For octene, they're on the fourth carbon making the fourth carbon on the longest carbon chain is making a triple bond with the fifth carbon. So let me just show that. Octene. Oops. Triple bonded to a carbon. Again, I'm going to be bending this a bit just because I'm running out of room. But again, on an exam, you guys wouldn't be doing that. Got it. Cool. And let me just check this real fast. 5, 6, 7, 8. Yep, perfect. One here. CH bonded to triple bonded to a carbon here. And as you can see, I'm not counting my hydrogens. The reason why I know these hydrogen, like how much hydrogens are off, if it's triple bonded, is due to practice. But again, it wouldn't hurt for you guys to draw the bond line structure and go from there, from here to there if you have enough time. If you're not sure about your hydrogens. 1 heptene. So on my first carbon is making a bond to my second carbon. Now, for this, you can write, instead of writing CH, some professors get very picky, and they want you to write HC. So you could depict it. And there's nothing wrong with that. This is just to show. Let me go down here. Again, on an exam, you guys wouldn't do that. Perfect. This is just to you can flip it on the left side just to show that my bond isn't to my hydrogen. I always thought it was kind of common sense, but you know, professors do professors, right? CH. Just gonna write CH. Triple bond. I'm gonna just keep it like that just because I have a habit. On an exam I would never write it CH. I would always write it HC. But just for this case example, I'm just gonna write CH. So alcohols. Naming an alcohol. Do you guys remember the rule about alcohol? The end of the suffix is gonna be OL, guys. And you're going to start off with numbering the alcohol. So, when you're naming this alcohol, you're going to go like this. Got it? Got it. So, the name of this is 1, because on the first carbon, I have the alcohol group. And then this is 3 carbons long, propanol. Let's start numbering this. Again, I'm going to start numbering this chain right here. The reason why you guys must be like, hey, why didn't you start numbering it from this carbon right here, right? It's attached to the alcohol group. Well, I can't leave my one of my carbons unattached. Then that wouldn't be the right IUPAC name for it, guys. Cool? Cool. Let me write it out. Perfect. Let's go down. This is a 7 carbon chain long molecule off the bat. The longest chain is going to be this, which again is obvious. This one I'm going to kind of go a bit slowly for you guys. I'm pretty sure if you guys are with me already, you guys are like flying through these, but if you're not, then this one I'm going to give you guys a bit of a breather on. That's a 7. And let's make this orange. Why not? Perfect. Guys, got it? Got it. My longest chain in this case was an heptanol, right? Not heptane, heptanol. Cool. And something has a lot of functional groups attached to it. There is a list that you have to follow in order to determine priority. So if you guys are taking the MCAT or any exam that's standard and you don't remember that list off the top of your head, it's fine. Just make a mnemonic for that list of the functional groups and always practice them. The more complicated molecules you name, the better you guys will be. Trust me. It will take a long time, but then eventually all these easy ones are gonna be literally laughable, guys. Laughable. Let me write the name for this. 3, 4, 5. So this is a 3-methyl. 3-pentanol. I can't forget that. Okay. Now I have to draw them. Right? Drawing these aren't going to be that bad. So this one, it always starts off easy. On the second carbon, there is a alcohol group. Let me just show you guys. Let me just draw it for you guys. So first, my longest chain is, use purple to depict this. CH3, CH, CH2, CH3. Second carbon, which is going to be 4. There is going to be a alcohol group attached to it. Fun fact, guys, only drink, don't ever try to drink anything with an alcohol group that's not, like, ethanol will kill you. So, pretty poisonous stuff. Yeah, it's crazy to think about it, right? Like, you're technically naming poison, huh? Like, you're naming something that could lethally kill you. Yeah. I always found that very interesting. Guys, got it? Got it. The rest, I'm just going to keep it in black. So, 3-ethylhexanol. So, off the bat, 3-ethyl, 1-hexanol. Excuse me. 1-hexanol means that my longest carbon chain is 6. It's a hexanol. And on my first carbon, there's an alcohol group. Let's do that real fast. This changes the amount of hydrogens attached to my first carbon. So instead of it traditionally being a CH3, now it's a CH2. Pretty basic stuff here. Oh, what am I naming? I'm naming the wrong molecule. Excuse me, guys. It's been a long day here. When your brain drifts off and you do another problem. CH2, 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 CH3. There you go. This one would be CH2, CH3. Perfect. Because this had 3 bonds to it. Let's go on. 2-methyl-1-propanol. That's a cool name, propanol. Well, 2-methyl-1-propanol. It's interesting. So you get propanol, which will be this molecule here. And there is a reason why I'm starting off with the CH2. Is because it's bonded on my first carbon. There's an alcohol group. So, OH. And on my second, there is a methyl. So if you keep that in track, you're pretty good. You usually never have to fly through these problems this fast, but on an exam it's usually much slower pace, and eventually when you figure out some things, you're good for multiple choices. But if you have a freestanding question, which in my university we mostly get freestanding questions for these type of things, which is amazing because that only means that you get really hard substituent, and you just have to provide one or a couple of IUPAC names for it, and it's like worth a lot of points because students often mess up on like a little dash here or something like that, or you have to draw one molecule. Well, that's everything, guys. Hopefully you guys can see right here. A real fast sum up is on my third carbon there was an alcohol group. Let me just do this real fast right here, as you guys can see. Right here, that's where the suffix came from. This is pentanol, which is my 5 carbon chain. So right here, and I had 2 on my second carbon. There was also a methanol right here, and I started numbering this molecule from this side over here. By starting numbering it, meaning that you will always start off by going here when you're drawing them. If you ask me, drawing is way easier than actually naming this molecule, because if I had to name it, it would still it stays true to its name. But yeah, thank you guys for tuning in today, and feel free, if you guys are confused or you want a way slower tutorial, watch my other video. It's 38 minutes long, but I guarantee you guys will learn a lot about naming alkanes. And from there, if you learn that, then organic chemistry only builds off of itself. You guys will do